This video will present details and code, schematics to smart irrigation system using Internet of Things. Content: why we need of smart irrigation system, sensors used, soil sensor, jumper wires, node MCU relay, water motor pump, humidity and temperature sensor. Pipe BLYNK connection. Code: advantage and disadvantage. Most of the farmers use large portions of farming land, and it becomes very difficult to reach and track each corner of large lands. Sometimes there is a possibility of uneven water sprinkles. This results in the bad quality crops, which further leads to financial losses. In this scenario, the smart irrigation system using latest IoT technology is helpful and leads to ease of farming. In March 31, 2018, 3 farmers died due to electric shock at the time of given watering to the plants, and so many cases of electric shock died farmers at the time of given water to the plants. Soil moisture sensor. Soil moisture sensors measure the volumetric water content in soil. Since the direct gravimetric measurement of free soil moisture requires removing, drying, and weighing of a sample, soil moisture sensors measure the volumetric water content indirectly by using some other property of the soil, such as electrical resistance, dielectric constant, or interaction with neutrons, as a proxy for the moisture content. Latest soil moisture sensor. Specifications: operating voltage, 3.3 V 5 V dual output mode, analog output more accurate, a fixed bolt hole for easy installation with power indicator, red, and digital switching output indicator, green, having LM393 comparator chip, stable panel PCB dimension, approximate 0.3 cm x 1.5 cm soil probe dimension, approximate 6 cm x 3 cm cable length, approximate 0.21 cm VCC, 3.3 V5 V GND old soil moisture sensor. Jumper wires. Jumper wires are simply wires that have connector pins at each end, allowing them to be used to connect 2 points to each other without soldering. Jumper wires are typically used with breadboards and other prototyping tools in order to make it easy to change a circuit as needed. Fairly simple. In fact, it doesn't get much more basic than jumper wires. Types of jumper wires. Jumper wires typically come in 3 versions: male to male, male to female, and female to female. The difference between each is in the end point of the wire. Male ends have a pin protruding and can plug into things, while female ends do not and are used to plug things into. Male to male jumper wires are the most common and what you likely will use most often. When connecting 2 ports on a breadboard, a male to male wire is what you'll need. Types of jumper wire: male to female, female to female, male to male. NodeMCU, ESP8266. NodeMCU is an open-source LUA-based firmware developed for ESP8266 Wi-Fi chip. By exploring functionality with ESP8266 chip, NodeMCU firmware comes with ESP8266 development board/kit, i.e. NodeMCU development board. NodeMCU Dev Kit/board consists of ESP8266 Wi-Fi enabled chip. The ESP8266 is a low-cost Wi-Fi chip developed by Espressif Systems with TCP/IP protocol. For more information about ESP8266, you can refer ESP8266 Wi-Fi module. Relay. A standard and generally used relay is made up of electromagnets, which in general used as a switch. Dictionary says that relay means the act of passing something from one thing to another. The same meaning can be applied to this device because the signal received from one side of the device controls the switching operation on the other side. Water pump motor, only for small projects. Specifications: operating voltage, 2.56 V operating current, 130-220 mA flow rate, 8120 L/H, maximum lift, 4110 mm continuous working life, 500 hours driving mode, DC, magnetic driving material, engineering plastic outlet outside diameter, 7.5 mm outlet inside diameter, 5 mm. Humidity and temperature sensor. Specification: supply voltage, plus 5 V temperature range, 0-50 degrees C error plus or minus 2 degrees Celsius humidity, 20-90% RH plus or minus 5% RH error interface. Digital. This DHT11 temperature and humidity sensor features a calibrated digital signal output with the temperature and humidity sensor capability. It is integrated with a high-performance 8-bit microcontroller. Its technology ensures the high reliability and excellent long-term stability. This sensor includes a resistive element and a sensor for wet NTC temperature measuring devices. It has excellent quality, fast response, anti-interference ability, and high performance. Pipe flexible PVC is a soft, flexible material that ranges in appearance from transparent to opaque. PVC is manufactured with plasticizers, which confer rubbery properties on the end product. By adjusting the type and amount of plasticizers, plastic molders can achieve a large range of flexible compositions. Since the plasticizers are small molecules, they can also escape the polymer more easily, which is the reason why PVC, also called vinyl, is often cited as a health and environmental hazard. This comes from chemicals called naphthalates, which are the real reason why PVC is soft. BLYNK app. Pavel Borodin, founder of BLYNK. BLYNK is a platform with iOS and Android apps to control Arduino, Raspberry Pi, and the likes over the internet. It's a digital dashboard where you can build a graphic interface for your project by simply dragging and dropping widgets. BLYNK is a new platform that allows you to quickly build interfaces for controlling and monitoring your hardware projects from your iOS and Android device. After downloading the BLYNK app, you can create a project dashboard and arrange buttons, sliders, graphs, and other widgets onto the screen. Open BLYNK app after registration, create new project. Name of your project, choose your device if you want to add new device. Create a button, do button setting, turn to push button, select your pin from hardware in which you connect. After all done, tap on play button, in which circle, tap on button. Code for BLYNK app. Hashtag include BLYNK.h blink library. Hashtag include ESP8266 Wi-Fi.h. Hashtag define LED16. Hashtag define BLYNK_print serial. Hashtag include BLYNK simple ESP8266.h char auth equals C408A477B304998CBB29C8A5F26696E9 char SSID equals Android AP char pass equals Chima 1234 void setup serial.begin 115200 BLYNK.begin auth SSID pass pin mode LED output void loop, BLYNK.run. This is the connections of Smart Irrigation System. Code of Smart Irrigation System. Hashtag define BLYNK_print serial. Hashtag include ESP8266 Wi-Fi.h. Hashtag include BLYNK simple ESP8266.h char auth equals G0QFAAVAEW5_BU5 chwat FQEMHWWAPXR, constant sensor pin equals 4, int sensor state equals 0, int last state equals 0, void setup, serial.begin, 9600, BLYNK.begin, auth, Android AP, mir ko nahi pata, pin mode, sensor pin, input, void loop, BLYNK.run, sensor state equals digital write, sensor pin, serial.println, sensor state, if, sensor state equals 1 and last state equals 0. Serial.println, needs water, send notification, BLYNK.notify, I am very thirsty, last state equals 1, delay, 1000. Else if, sensor state equals 1 and last state equals 1, serial.println, has not watered yet, delay, 1000, else, serial.println, I am full, last state equals 0, delay, 1000, delay, 1000. Advantages of Smart Irrigation System 1. To save water 2. Smart irrigation also deals with efficiencies in the delivery of the water. There are generally 4 types of delivery: surface, sprinklers, trickle, and subsurface methods. 3. It distributes water through irrigation ditches, letting gravity do the work. 4. Sprinklers distribute water through the air like rain and can be fixed or mobile. 5. Trickle irrigation spreads water very locally to the ground surface. 6. Controlling these two set points reduces the amount of water used by linking it to the moisture level needed in the soil for a particular crop. 7. A particular land area is too dry and starting an irrigation routine, or to stop irrigation when a particular saturation point is met because a soil moisture level has been reached. 8. Use local soil moisture data drawn from sensors in the ground to support informed decisions about watering schedules. Disadvantages of Smart Irrigation System 1. Agriculture being a natural phenomenon relies mostly on nature, and man predict or control nature, let it be rain, drought, sunlight availability, pests control, etc. So ever implementation IoT system agriculture. 2. The smart agriculture need availability on internet continuously. Rural part of the developing countries did not fulfill this requirements. Moreover, internet is slower. 3. Fault sensor or data processing engines can cause faulty decisions, which may lead to overuse of water, fertilizers, and other wastage of resources. 4. The smart farming-based equipment require farmer to understand and learn the use of technology. This is the major challenge in adopting smart agriculture framing at large scale across the continues. 5. It also has some issues which have to be tracked properly in order to attain the full benefit of it. 6. The current IoT systems are not scalable or reliable, and the initial costs are high which the farmers cannot afford.